Hello everyone. In this video, we are going to understand distributed system in a very simple and practical way. I'll explain everything using a real-time example called Pet Social app. So even beginners can easily follow along. Imagine you built a small social media app called Pet Social app, where people upload their photos of their pets. You write the code, you set up a database, and host it in a single server. Here, the single server in the sense your computer runs your code. Okay, so and you launch it. So you launch your application, and your friends love it. You have 50 users suddenly. So everything is fast, smooth, and running perfectly. But one day, one of our celebrity posts a tweet about your app in social media. Suddenly, you go from 50 users to 500,000 users in 1 hour. So 500,000 users try to access your app at the same time, and boom, your server crashes. Why? One machine cannot handle it. This happens because your application is running on a single server. The single server cannot handle so many users at the same time. When too many requests come into your app, the system becomes slow or completely stops working. This is the exact problem distributed systems are designed to solve. A distributed system is a group of computers working together as one system. So, to the user, it feels like a single application, but behind the scenes, multiple machines are working together. Big companies like Google, Meta, Microsoft, Amazon, and Netflix, etc., all uses the distributed systems only. Yeah, think of a few pizza shop here with one chef. Suddenly, 10 customers come into the shop, order a food. So everything is fine. So one chef can handle 10 customers easily. But imagine if 1,000 customers arrive at the same time, and then think about the chef, he will collapse. He or she will collapse. So the solution here is hire more chefs to fix the problem, right? So in the distributed systems works the same way. More machines doing work together. Here, scaling means simply means like handling more users or more load. There are two main ways to scale a system. That is vertical scaling and horizontal scaling. Here, vertical scaling means making one machine stronger. So that means you're adding more RAM, a faster CPU, or more storage. This is easy to do, but there is a limit. And if that one machine fails, your entire application goes down. Here, horizontal scaling means adding more machines instead of making one bigger. Okay, so you distribute the workload across multiple servers. This is more complex, but it is how large scale systems work. Companies prefer this approach because it can scale almost infinitely. Here, horizontal scaling is more reliable. If one server fails, other can still handle your requests. So this makes the system fault tolerant and highly available. So now the question is, how do users know which servers to connect to? That's where the load balancer comes in. Actually, a load balancer sits between the users and servers and distribute the traffic evenly. The main advantage of load balancer is not only distributing the topic, it prevents the server overload and improve the performance and increases the availability and enables scaling. Detects easily unhealthy service. Okay, all these things the load balance can do. There are different ways a load balancer works. One, round robin. Two, least connections. Three, IP hash. Okay, usually round robin send requests one by one to each server. Okay, that means like you got three requests and you have three servers. See, it's equally distributed. Number two, least connections. Usually, least connections send traffic to the least busy server. And the third one, IP hash. IP hash sends a user to the same server every time. These are the types. Versus throughput. Okay. So latency means how fast a single request is processed. So throughput means how many requests the system can handle at the same time. Think of a latency as a speed and a throughput as a capacity. So both are very important concepts in distributed systems. So till now we discussed about scaling application servers. So scaling application servers is easy, but if you want to scale the database, it's hard. So if many servers connect to one database, that database become a bottleneck, right? So there are some special strategies to solve this problem. One of the strategy is replication. So in replication, we have a master and replicas. Okay, all database writes will go to master. All database reads will come from replicas. So with master and replicas, right? With replication, the performance improves very significantly, right? So regarding replication, like I'll tell you an example. Imagine you have built a food delivery app called Food Express. Okay. At first, only a few people use it and everything works fine. But one day, thousands of users start using your app at the same time. They are browsing restaurants, checking menus, and placing orders. Okay. All of this data goes to one database. Very quickly, the single database becomes slow, overloaded, and eventually crashes, right? This is where data replication comes in. Data replication means copying data from one main database to multiple other databases so that the load can be shared. Okay. In replication, we have one primary database and multiple replica databases. The primary database handles all write operations like placing an order or updating a profile. Okay. The replica databases handle read operations like showing menus, order history, and user details. So when thousands of users are reading data, they are not hitting one database. The load is distributed across many replicas. So this makes the system faster and more reliable. Okay. Yeah, replication is good and but not perfect. There is a small delay before data reaches to replicas, right? This is called replication lag. So it causes something known as eventual consistency. What is exactly eventual consistency means the system does not update all the data immediately, but after some time, all copies will be become consistent. But there is a small lag is there, right? So that is the problem with the replication. So we discussed about eventual consistency, right? We'll talk about another concept like sharding. When the data become too large, we have to split it across multiple databases. This is called sharding. So each database stores only a portion of a data. Okay. So for example, users with IDs 1 to 1 million goes to server one. Users with IDs from 1 million to 2 million goes to server two. So like that, this will allow system to scale to billions of users. Okay. So once we share the data between multiple servers, so here sharding introduce complexity. Queries become harder, right? So transactions across database are difficult. That's why sharding is used only when absolutely necessary. Okay. Okay. Let's summarize. So distributed systems help applications scale easily, and load balancers like a distributed traffic, and databases require replication and sharding. So this is how modern applications handle millions of users. Okay. So that's all for today, guys. Thank you for watching. If you found this helpful, like the video and subscribe. In the next video, we'll discuss microservices versus monolithic architecture. Thank you so much.